354 components. The smallest one is thinner than a human hair. They are assembled entirely by hand, in a climate-controlled room, by people who trained for 7 years. And together, they keep time to within 2 seconds per day for 100 years. This is how a $50,000 mechanical watch is born.
This video is created using artificial intelligence tools for education purpose only. All information is based on real and verified research.
Le Sentier, Switzerland, altitude 1002 meters above sea level. For over 2 centuries, this valley has produced more precision mechanical timepieces than anywhere else on Earth. Inside this building, one of the world's last true in-house manufacturers, every component of every watch is made, assembled, and tested in a single facility. We were given rare access. Temperature is maintained at exactly 20 degrees Celsius year-round. Humidity at 45%. Every person entering passes through an air shower that removes dust particles larger than half a micron. A single fleck of dust on a watch escapement is enough to stop it completely. The enemy of precision is invisible. These are the 354 components that make up a single watch movement. The mainspring you see coiled at the top stores enough energy to run the watch for 72 hours. The smallest component, this hairspring, oscillates 5 times per second and controls the accuracy of every other part in this system. Together, they will fit inside a case the diameter of a 2-pence coin. The mechanical watch is 300 years old. Every principle inside it, the escapement, the gear train, the balance wheel, was invented before electricity existed, before computers, before precision machining. They were solved by genius alone. And today, inside this factory, we use billion-dollar CNC machines to produce components to tolerances of 1-micron tolerances that the original inventors could only dream of. The base material for most watch plates and bridges is a specific copper-zinc alloy containing exactly 63% copper and 37% zinc. This formula has been the industry standard since the 1870s. It machines cleanly, resists corrosion, and accepts plating without warping. Every bar is certified and tested before it enters the factory floor. The certification is more important than the price. The main plate, the foundation of the entire movement, is machined from a solid brass blank on a 5-axis CNC center. 500 individual cutting operations. 93 separate holes drilled to tolerances of 1 micron, that is 1/1000th of a millimeter. The machine takes 47 minutes to produce 1 plate. A human would take 3 days and could never match this precision. These are synthetic ruby jewel bearings, and they are one of the most elegant engineering solutions ever devised. Rubies have a hardness of 9 on the Mohs scale, second only to diamond. In a watch movement, they act as frictionless bearing surfaces for the rotating pivots of each gear. A movement with 21 jewels will run for decades without any measurable wear at its bearing points. This is why vintage watches still work perfectly after 100 years. Each gear in the movement has teeth cut to an involute profile, a specific mathematical curve that ensures perfectly constant velocity transmission regardless of the gear's rotational position. This curve was first described by mathematician Leonhard Euler in 1754. Every gear in every car, every clock, every turbine on Earth uses the same principle. The watch just does it at a scale that requires a microscope to see. The mainspring is the energy source for everything. This ribbon of hardened steel alloy Nivaflex, a nickel, cobalt, chromium, molybdenum compound, stores enough potential energy when fully wound to run the movement for 72 hours. The energy it releases per second is calculated in microjoules. Engineers spent years perfecting the barrel design so that power output remains constant from full wind to near empty. This is called isochronism, and it is why your watch is accurate. This process is called anglage, and it has no functional purpose whatsoever. Every interior angle of every bridge and plate is hand beveled to a 45-degree chamfer and then mirror polished with a wooden pegwood stick and diamond paste. The chamfer you are watching being created is 0.2 millimeters wide. It takes 30 minutes to complete 1 bridge. A movement has 23 bridges. This is the work that separates a great watch from a masterpiece. CTS de Genève, Geneva stripes. These parallel lines decorating the plates and bridges have been the signature of fine Swiss movements since the 19th century. They serve no mechanical purpose. Their only function is beauty, and the signal that someone cared enough to finish the interior of the watch as carefully as the exterior. You will never see these stripes unless you open the case back. The watchmaker decorated them anyway. Perlage. The internal surfaces of the baseplate receive this overlapping circular decoration, each circle made by a wooden rotating peg loaded with polishing compound, moved in precise rows. The finished effect creates a matte pearl-like texture that prevents light reflection inside the movement case. It has a practical purpose, and it is also one of the most beautiful textures in all of manufacturing. Rhodium plating. Rhodium is one of the rarest metals on Earth, 60 times rarer than gold. An electrical current drives positively charged rhodium ions from solution onto the negatively charged bridge surface, depositing a layer less than 1 micron thick. This invisible coating is harder than steel, completely corrosion-proof, and maintains the exact surface finish of the finishing work underneath for 100 years. Every screw securing the bridges to the baseplate has its head hand polished to a mirror finish. This screw head is 0.8 millimeters in diameter. The polishing is done on a rotating zinc disc with 1 micron diamond paste. The process takes 8 minutes per screw. A movement has 42 screws. The reason, when light enters the movement through the caseback, every surface, every screw head, must be worthy of it. This is the escapement, and it is the most important mechanical invention in human history. Everything you see moving here works together to do one thing: release energy from the mainspring in exactly controlled, equal increments. The escape wheel advances one tooth at a time. The pallet fork stops and releases it. The balance wheel controls the rhythm of the fork. 5 beats per second, 432,000 beats per day, every single day for 100 years. The hairspring, 15 millimeters long, 0.015 millimeters thick, that is 15 microns, 1/4 the diameter of a human hair. This spring oscillates 28,800 times per hour and controls the accuracy of the entire watch. A variation in its geometry of 1 micron changes the daily rate by 30 seconds. Every hairspring is individually regulated under a microscope. It takes a watchmaker 3 years of training before they are allowed to touch one. Balance wheel regulation. The timing machine measures the watch's rate in real time, seconds gained or lost per day. This particular movement is running at plus 2.3 seconds per day. The watchmaker moves a regulation weight on the balance wheel rim by less than 1/10 of a millimeter. Now the rate reads plus 0.4. That is 4/10 of a second per day. The Coast chronometer standard requires accuracy within -4 to +6 seconds. We're already better than that. Assembly begins. The main plate is placed in a movement holder, and the first bridge is positioned. Every component is picked up only with tweezers, never fingers. Skin oils contain salts that cause corrosion on steel pivots. The watchmaker works in silence. No music in this room. Sound is information. The click of a bridge seating correctly, the slight resistance of a screw that's slightly misaligned. You listen as much as you look. The gear train 5 wheels, in series, forming the power transmission path from mainspring to escapement. The barrel wheel makes 1 revolution every 7.5 hours. The center wheel, 1 revolution per hour. This drives the minute hand. The fourth wheel, 1 revolution per minute. This drives the second hand. Each wheel steps up the speed and reduces the torque of the previous one. 60 years of engineering in 5 components. Casing up. After weeks of machining, decoration, and assembly, the movement is placed into its case. The stem is fed through the winding crown. The case back is pressed on with a case press, compressing the rubber gasket to a waterproof seal rated to 100 meters. From this moment, the movement is invisible. The craftsman's work is hidden inside a sealed container. The watch is now complete. We have never built a more ironic object.
Before the watch leaves the factory, it undergoes 16 days of chronometric testing, the official COSC certification protocol. Each movement is tested in 5 different positions: crown up, crown down, crown left, crown right, dial up, at 3 different temperatures. Only watches achieving accuracy within -4 to +6 seconds per day in every position, at every temperature, receive the chronometer certification. Fewer than 3% of watches produced worldwide pass this test.
Water resistance testing, 10 bar equivalent to 100 meters underwater. The pressure chamber simulates a descent no recreational diver should ever make. Any microscopic failure in the crown seal, the crystal gasket, or the caseback rubber O-ring
will allow water ingress within seconds. A failed watch is stripped, the caseback seal replaced, and the test is run again. We pass 100% of our production. We test 100% of our production. The breakdown: 354 components, $4,200. Decoration and finishing: anglage, perlage, CTS de Gen V. Screw polishing: 8,547 hours of master watchmaker labor, 18,800. Chronometer testing and quality control, 3,100. Case machining and bracelet, 7,400. Total cost to produce, $50,000. The margin, after retail costs and warranty obligations, it is not what most people assume. This is the result: 354 components, 47 hours of master-level craft, 16 days of testing. The balance wheel you see oscillating through that sapphire crystal caseback will beat 5 times every second, every day, for the next 100 years, wound only by the motion of the wrist it sits on, requiring no battery, no satellite signal, no software update. It is a purely mechanical brain that tells time using nothing but steel, brass, and the principle of energy conservation. It is by any reasonable measure a miracle. If this video changed how you think about what precision actually means, subscribe.